Yes, hope all of you are doing great. I'd like to welcome each and every one of us to my channel of Honest Sciences and Mathematics TV channel. Today we're going to look at an interesting concept of some of the physiological effects which are going to be realized due to the presence or absence of an element in a biological system. And in this case, basically, we're going to be looking at the concept of deficiency of some of the, of course, elements which we have come across, particularly from our previous videos. Now, basically, it's shown that we can have this specific aspect of what we refer to as an essential element, which we said that this element can be classified as essential if it's withdrawn from an animal diet. It's going to be having some severe or, of course, irreversible damage to the body of an organism. Therefore, we say that it's going to be essential for this specific element to be, of course, biologically available for this specific organism's body to function optimally. And therefore, we had stated a few of the terms which we are going to come across, especially under this specific concept of course, the concept of health response against the dose of an element, whereby I had given this one using a specific illustrative curve, which I like to encourage our members to be checking on, particularly of the response of this specific organism against the dose of these, of course, elements. And in this case, we had listed a section for survival, deficiency, optimum, and then we said about toxicity, and the last one was the lethal dose of these specific essential elements. And this one assisted us define a specific window which is going to be optimal for the animal to survive under the presence of these specific essential elements. Now, in a sense, we're going to look at the deficiency of these specific elements and some of their symptoms, which are going to be, of course, indications showing whether this organism is going to be, of course, body is going to be acting optimally or not. And therefore, we can just list a few examples. There are many others which we're going to come across in a various set of literature, but in this particular case, I'm just going to look at this specific set for just our illustration purposes. So if we see that this is specific, of course, element which we have talked about, which is calcium, if it is going to be deficient in the, of course, body of an organism, this is going to be causing retarded skeletal growth. And as we said, of course, our bone structure is going to be containing this specific element of calcium, which is going to be forming the main structure of this particular, of course, skeletal system, especially in organisms like man. Now, in a sense, we are going also to see that the absence of iron is going to be causing a condition of anemia. And magnesium, the absence of magnesium or in a deficient amount is going to be causing muscle cramps, while manganese is going to be, of course, causing a condition of infertility. And growth depression is going to be realized due to the deficiency of nickel. And of course, the deficiency of molybdenum is going to lead to retarded cell growth and, of course, thyroid disorders due to the deficiency of iodine. And these are some of the examples which we are going to be coming across, and of course, we shall be mentioning them as we go by. Now, I'd like us to look at some of the additional, of course, terms which we're going to come across in our various discussions under the concept of course, these specific physiological processes. And of essence for us, we're going to be concentrating on what we refer to as enzymes and, of course, enzymes and proteins, which in a sense we are going to see that these specific molecules are going to be related, but our discussion is going to assist us to differentiate between the two in case we come across them, and there are various range of activities in biological systems. Now, we have come across these specific terms and said that these are going to be a set of chain of amino acids, which are going to combine to form what we refer to as, of course, proteins. So this is going to be a chain of amino. My handwriting is legible. So this is going to be a set of a chain of amino acids. So therefore, the building blocks of proteins are going to be amino acids, and we talked about the concept of enzymes, and we can define enzymes as proteins. So this is a set of proteins with catalytic properties. And in our chemical kinetics, we have talked about this specific aspect of a catalyst and the effect of this one, especially on the concept of activation energy. And therefore, we are going to see that, particularly for enzymes, these are going to be proteins in nature, which are going to be having catalytic properties. Now you can just give a relationship between these proteins and of course enzymes, whereby we are going to have these ones as a set of biomolecules given as such. And in our definition of this specific concept in our first video, I said that we're going to have a range of biomolecules that constitute of carbohydrates, lipids, and of course other of course molecules which we're going to see like the nucleic acids, of course etc. So in a sense, we're going to see that proteins are going to be a set of biomolecules which we can list as such. And of course, we're going to see that some of them are going to be non-proteins, and therefore we can have this one given as such. So we shall have this one as proteins as a set of biomolecules, and non-proteins, which is another division of these specific biomolecules. But under proteins as I've just defined this one, we're going to have this specific set of proteins with the catalytic properties regarded as enzymes. Now the two of them are going to be forming a set which we are going to see later, that is going to be consisting of what we refer to as cofactors. So in a sense, the concept of cofactors is going to be entailing what we refer to as proteins and non-proteins, which are basically going to be defined as helper molecules that are going to be bound to either a protein or an enzyme in order to, of course, assist it, of course, perform its activities. Now, in a sense, we're going to be looking at this specific set of cofactors, and these are going to be described depending on how tight they are going to be bound, of course, to an enzyme or a protein. So in this sense, I can just give a small illustration of this specific definition, whereby if we are going to have a protein of this specific nature, so we shall have this one, perhaps given as this one for illustration purposes. So I'm going to have this one given as such. So this is going to be a protein. And of course, if we have this specific protein given as such, we can define this other one as a cofactor. So basically, this cofactor is going to be made up of these specific, of course, categories which I've listed for proteins, enzymes, and non-protein molecules. And therefore, we can define these specific, of course, molecules as cofactors, which are going to be helper molecules that are going to assist this specific set of molecules perform their specific activities. Now, in a sense, we're going to see that this is going to be achieved by a combination of a molecule of inactive, either inactive protein or enzyme in this specific case. And a cofactor is going to be, of course, joining with this specific inactive protein or enzyme, this specific site that we call an active site. And this specific site is going to be, or perhaps we can just give it in terms of a binding site. A binding site. So this binding site is going to be, of course, ensuring that this inactive protein has been joined with a cofactor in order to activate it for its specific activity. And therefore, these are some of the terms which we are going to come across, especially the cofactors. And of course, we are going to come across inactive and active kind of enzymes and the binding site given as such. So we can categorize this specific aspect of cofactors, of course, in two different sets, which depends on how tight they are going to be, of course, attached to this specific kind of an enzyme or proteins. So therefore, we shall have two sets of this specific kind of cofactors which I've mentioned, which can be given in terms of tightly bound. So the ones which are going to be tightly bound are to the binding site or to the protein molecule, and the ones which are going to be loosely bound to either the enzyme or the protein molecules given as such. And these are going to be constituting a various range of course, what we refer to as a prosthetic group. So these which are tightly bound are referred to as prosthetic group of cofactors, and the ones which are loosely bound are referred to as a coenzyme. So in case we come across these two specific definitions that we are going to give for the prosthetic groups, this is going to be referring to tightly bound cofactors which have been bound to a protein, whereas the coenzymes are going to be loosely bound type of cofactors to the proteins given as such. So there are some specific terms which we are going to come across, of course, which are going to be as well assisting us try to define a protein or an enzyme which is going to be containing a cofactor. So in this case, if we have an enzyme, so perhaps I can give it as such. So in case we have an enzyme with and without a cofactor, we're going to refer to this as specific enzyme with a cofactor or with a cofactor given in terms of a holoenzyme. So this is another term that we're going to come across for holoenzyme, which refer to an enzyme without a cofactor, whereas the enzyme without a cofactor is referred to as Apoenzyme. And similarly for a protein, which we are going to be having for this specific case, which is going to be with a cofactor, is going to be referred to as a holoprotein. And of course, a protein without a cofactor is referred to as an Apoprotein. So it will be essential for us to try and understand these specific prefixes which we are going to use for holo and apo for the two kinds of proteins which we have given for enzymes and proteins. And they are going to assist us in trying to define some of the terminologies which we are going to come across in our various discussions on the concept of enzyme and protein activities in our subsequent videos. Now, in this particular case, I can just give an example of a few co-enzymes which we are going to come across or rather cofactors which we are going to come across in our discussions, or rather which we have come across in some of our discussions. And this, of course, are going to constitute examples of cofactors. So one of the examples of the cofactors which we are going to come across in our discussions is Heme. So I talked about this specific molecule, protein molecules, which is going to be, of course, involved in the transportation of oxygen around the body, which we're going to be coming across. And we shall look at another one referred to as a Biotin, which is also another type of cofactors. So among others, this is going to constitute coenzyme A and B. And of course, we can just look at an example of these ones as well as these specific molecules which we're going to come across. So in a sense, there's going to be a range of some of the cofactors which we're going to come and describe perhaps or discuss them in details in some of our videos which we're going to come across. And this is going to assist us try to pinpoint some of the functions which we are going to come across in our various videos, especially on the concept of bioinorganic molecules. So catch us in our videos and other videos which we are going to be doing on this specific topic. And kindly check our description boxes for various links of other videos, and also engage us in the comment section and ring that notification bell for other updates on different discussions in math and sciences. So that is it for now, guys. By God, please. We'll catch us in our next video.